Section 5.3, Part 2 of Mathematical Induction, Application. So when are other times that we might be able to use this induction? Here's a preview of one place that we might be able to do it. But I'm going to start by looking at divisibility. So here, n is greater than or equal to 0, and let's then show that 2 to the 2n minus 1 is divisible by 3. So again, I'm going to identify the property. I'm going to look at my basis step. I've got my hypothesis step, my assumption, and then again, I clearly state out this is the thing that I want to show, so that again, I know what it is that I'm looking for. And then, of course, the body of the proof is how do I get from the one to the other? And again, we've got our textbook author talking through the process behind it. And again, I'm going to skim to my proof so you can see it. So again, here's my induction step. Here is my assumption. And you'll notice I'm going to write that out. So 2 to the 2k minus 1 is 3 times m, ram's an integer. And again, here's clearly the thing I would like to show. I distributed that 2 in the exponent. You'll also notice I'm writing as 2 times 2 to the k times 2 squared, which is also 4. So I did do a little bit of rewriting there right away, just to kind of help me see more easily where I'm trying to get. So I'm going to look at equation 1, and I am going to add 2 to the 2k minus 1 to that equation 2 times. And do note that both of those terms are divisible by 3. So I've got 3m, I'm adding it 2 times, and I'm going to do that on the right-hand side as well. Well, on the right-hand side, I've got 3 of them, so I can write it as 3 times 2 to the 2k minus 1. We've already said that's an integer, so I have something in the form of 3 times an integer. That is divisible by 3. All right, let's try another one with an inequality. I've got 2n plus 1 is less than 2 to the n, and we're starting with n is greater than or equal to 3. So wherever we are given to start, that's where we start. So here I'm going to start at 3. On the left-hand side, I've got 7, and the right-hand side, I have 8. So yes, that is a true statement. As you can see, I have my clear assumption step, and I am going to do a little bit of rewriting here. I've got that as 2 times the quantity k plus 1, and then I'll turn that into a minus 1 in order for it to be the same thing. And that is partly because I knew what I was going to need going ahead. But again, let's clearly state out what I want to show is true, and writing that out a little bit more neatly on the left-hand side, I will end up with 2k plus 3. So looking at equation 1, I am going to add 2 to both sides of it. And again, you'll notice I'm using my rewritten version so that we can see that I do then get the 2k plus 3 very neatly on the left-hand side. And if I add 2 to the right-hand side, well, I can express that as 2 to the k plus 1. And, well, that is less than 2k is less than 2 to the k plus 1. So it will then follow that this line is also true. Do note here, because I have inequalities, I can have a little bit more freedom in what I do than with an equality. As long as I'm confident that something is less than something else, then I can use that as an inequality. All right, let's look at something with a sequence. So here I've got a sub 1 is 2, and then to go along the sequence, a sub k is 5 times a sub k minus 1. In other words, the previous term, I take that and multiply 5. So let's first write the first 4 terms. So again, we start with 2. 5 times 2 is 10. 5 times 10 is 50. 5 times 50 is 250. So again, I'm using that previous term to build up to the next term. And here is then our induction once we've got that. And again, here's your textbook author going through some of it. And I'm going to skim through that so that you can kind of see where it's coming from. We've got that induction, we've got the assumption, and then we are clearly stating out what we want to get. So here, again, we might rewrite this a couple of ways. I've got that 5 to the k plus 1 minus 1 is the same as 5 to the k. And again, looking at that definition, I can then write that as 5 times a sub k. And we've already made an assumption about that we can write it as 2 times 5 to the k minus 1. So at that point, I'm just going to change the order of my terms and then simplify to get 2 times 5 to the k. And that is exactly what I want it to show. And that is everything in section 5.3.